Connect. With this research, we propose blockchain and self-sovereign and identity empowered, privacy-preserving digital contract tracing platform. So we mainly propose this platform for COVID-19 outbreak control situation, but it can be used in any pandemic scenario to contact tracing and activity tracing. So these are the authors of this work. So I am the presenting author, Iranga Bandara. First, I will give a bit introduction about me. I'm Eranga Bandara, working as a senior project scientist at VMAS, Virginia, USA. I'm involved with various projects on blockchain, distributed systems, cybersecurity, machine learning, federated machine learning kind of areas. So actually, our main goal of doing research is we always try to do research and build production grade applications based on these researchers. So we just not satisfied only having a publication. We always trying to make a production grade application. So based on our researchers. So Connect is one such platform. We have built various such platforms. So we built blockchain platforms, federated learning platforms, distributed applications, mobile applications. So such applications. So all are based on the our researchers. I'm available on Twitter, so this is my Twitter username. If want, we can contact via Twitter as well. Okay, let's look at some background information about Connect platform and how we propose contact tracing via this Connect platform. Uh, it's a privacy preserving contact tracing platform which built with blockchain and self-sovereign identity. Connect mainly target for COVID-19 contact tracing, so but it can be used for any pandemic scenario to contact tracing in a privacy preserving manner. So our main goal is guarantee the privacy of the data, users data while doing the contact tracing. So for this work we have collaborated with the Centera Hospital chain Virginia, USA. So we built production ready platform of Connect with collaborating with Centera. Okay, so currently there are various contact tracing platforms available. Various providers propose different contact tracing solutions. So the main concerns we need to satisfy of the contact tracing is the contact tracing platform should guarantee the privacy concerns of both potential patients and the people they could come in contact. So, but most of the existing contact tracing platform lack of these privacy features. So they suffer with data centralization, privacy concerns, and location tracking kind of concerns. So the main thing here is the centralization of the user personal data in a cloud environment can be vulnerable to various attacks. So we shouldn't store all the personal data and contact tracing data in a cloud based centralized system. So, with this research, we propose blockchain and self-sovereign identity empowered decentralized contract tracing platform to address the privacy concerns on the centralized contract tracing platforms. Actually, most of the existing contract tracing platform built with centralized architecture. Instead, we try and use blockchain and self-sovereign identity empowered decentralized architecture for the contact tracing. So Connect self-sovereign identity-based identity wallet encodes users' digital identities and activity trace data on the permission blockchain platform and verify user SSI proofs. Actually, we propose mobile wallet application for the users. So and admin also we provide two mobile wallet applications. So by using these mobile applications, users can record their identity information as well as contact tracing information on privacy preserving manner. So all the actual information, identity and contact tracing information, so activity tracing information stored on the user's physical mobile wallet. The proof of the data will be stored on the permission blockchain. So it won't reveal the permission in private information of the users. Okay, so user identity information include personal information, images, ID information, kind of things. The user activities will provide information such as places, travel and dispatch updates information, location, time, etc. So in here, the activity trace record can be leveraged to identify the suspected patient and notify the local community in the real-time manner. So all the data record which corresponding to the activities, so activity trace data so is used to identify the suspected patients which contact with the COVID-19 and notify to the local community. Okay, so let's look at the Connect architecture, how we have built the Connect platform. Uh, So this is the high-level architecture of the Connect platform. So we have four major layers. So distributed ledger, DID communication layer, credentialing layer, and activity trace layer. So distributed ledger is the basically blockchain-based storage which store all the users' DID proofs, actually that identity proof as well as activity trace proofs. So DID communication layer. So it used to handle the peer-to-peer communication. Actually, we provide two type of mobile wallet applications. So connect mobile wallet application for the users, so trace mobile wallet application for the admin authorities. So actually that credential owners are the connect users, so credential verifiers are the trace users. Basically connect credential owners capture their all the personal information and in their mobile wallet application, so and stored on their local mobile wallet. So then credential verifiers can verify these identities by directly fetching those information from the users connect mobile wallet. In that case, peer-to-peer communication handled with the DID communication layer. So there's a credentialing layer, actually that credentialing capturing and credentialing verification happen in the credentialing layer. So then activity trace layer, all the activity trace records tracked on the activity tracing layer. Okay, so let's look at so each and every layers, so with more information. So first, distributed ledger. So distributed ledger is the blockchain based peer-to-peer storage system used in the Connect platform. All users crypto artifacts, so basically we identify as a DIDs, decentralized identities, and proof of the active trace records are stored in the distributed ledger. So in here, the blockchain can be deployed among multiple organizations such as government organizations, hospitals, airports, custom officers, banks, this kind of organization. So each organization in the network can run their own blockchain node. These nodes connected as a ring cluster. So these how it look like. So there will be multiple nodes. So each node there will be admin authority in there, admin officers basically. For instance, bank. So there will be bank teller would be the admin person. So in here there's another PS called type called users. Users will have the connect mobile wallet. So admin will have the trace mobile wallet. So basically users will capture all the informations via personal information. So via this connect mobile app. So then admins will verify those information and do the contact tracing as well via the trace mobile wallet. So then DID communication layer. So that's the next layer. As mentioned previously, two type of users, credential owners. Basically, they provide the connect mobile wallet. Credential verifiers are the admin authorities. So they will give a trace mobile wallet. So DID communication used to exchange the actual credential information. So basically user images, numbers, and etc. between users to verifiers mobile wallet. So these exchange happen via the peer-to-peer channel. So actually credential verification, we need to exchange all the actual credential information we stored on the users connect mobile wallet. So then there's a peer-to-peer communication between users mobile wallet and the admins trace mobile wallet. This exchange happen via DID communication layer. So then credentialing layer. So basically credential owner registers their DID proofs. Basically they capture the information and generate a DID proof of this information and saved on the blockchain. So and enrolled to the Connect platform. So then admins, basically credential verifiers, verify these DID proofs via trace mobile wallet. So then credential registration verification happened in the credentialing layer. So basically different entities in the platform, users, admin, create and exchange credential for verification via the credentialing layer. Then activity trace layer. So basically all use activity trace data in the Connect platform are stored in the permission blockchain ledger based on self-driving approach. So basically actually that all the activity trace data also stored on users physical mobile wallet. So the proof of this data will be stored on the blockchain as a self-sounding and proof. So for instance, when a user goes to a specific place, airport, bank, hospital, or any office, so the admin officer there can verify the identity of the user and create an active trace record. So in the blockchain, so basically proof will be recorded on the blockchain. Actual active trace record will be stored on the user's connect mobile wallet. So then admin also can fetch this active trace record from the blockchain as well as from the connecting to the user's connect mobile wallet and verify them. So all the active tracing functions handle with the active trace layer. Okay, so connect functionality. So let's look at some scenario and discuss about the connect functionality. So consider some scenario where blockchain network is deployed at airport, hospital network, government bank, and IT office. So then admin officer at each organization so install the trace mobile wallet app. So assume a user, and user comes from overseas, and when he comes to the airport, he installed the Connect mobile app and registered in the Connect platform. So that's the basic scenario. So user will have the Connect mobile wallet when he enter into the airport. So he register his identity and enroll to the Connect platform. Okay, so there's a first step is identity registration. Basically, it involves the user and Connect mobile wallet. So this is the identity registration feature on the Connect mobile wallet. It will capture all the personal information, image, and signature also can be captured. And once captured, it save this information on user's personal mobile wallet. It won't upload this information to any place. So once when registering, it will generate a public private key pair for this mobile wallet. So private key will be stored on the key store on the mobile wallet, and we'll generate a DID. It's called decentralized identity based on the public key of this mobile wallet. So that DID will be embedded to the QR code of this mobile wallet application. So then user can show this QR code at any place in the Connect network. So to prove his identity. So this is the registration work. So basically how that DID upload, this is how DID upload or registration work with the blockchain. So it generates the DID. So this is the DID format, DID connect. This is the BS58 hash of the public key. So it will be uploaded to the blockchain. So this is the example DID record saved on the blockchain. You can see that it won't save any personal information or anything, just a DID. So that's the thing. Okay, so then identity verification. Actually, that user registered. So in first time, user need to verify his identity by using authorized person in any network. For instance, in that case, user comes to the airport. The identity verification can be done with the airport. It can be done with any place, maybe bank or any organization in the network. So basically that in that case user comes from the airport, user shows the QR code to the custom officer or any officer in the airport or any other place. So then officer will scan this QR code by Trace mobile wallet and fetch the user's actual identity information via directly connected to the Connect mobile wallet application. This is the place where peer-to-peer communication happens. So then it will display all these information. In first time using, so user need to get a approval for this identity. That means it's a kind of vetting process. In that case, user need to show this QR code along with his physical ID. It could be passport, national ID card or any ID card which can prove the user's identity. So then what officer do is, officer compares the actual information he saved on the Connect wallet against the physical ID. If details are matched, officer will approve that identity. So that's the identity verification process. After verified or approved the identity, user can use this identity to any other place to prove his identity. So just showing the QR code. So then it can trace the activity records as well. So that's how identity verification works. So this is basically how it works. User with Connect app shows the QR code to the officer. So then officer scan the QR code. So then it connect to the blockchain and verify the DID proof. So then blockchain will verify the DID proof. Then it directly contact with the user's Connect app and fetch the actual ID information from the Connect mobile wallet and display. So that's how it works. So then activity tracing. So let's see how activity tracing works. So basically after identity verified by the admin, so user can goes to any bank or state office, and when going to this office, so he can just show this identity wallet QR code to prove his identity. So in that each point user shows his identity QR code in the wallet to the admin officer. Then admin officer scans the identity and verify it. So when verification, it automatically creates an active trace record proof in the blockchain. Actually, it will be create active trace record. So active trace record contains information about user identity, basically its DID, time, location. So this kind of information. So actually, the actual information, this information will be stored on the user's Connect mobile wallet, or the proof will be stored on the blockchain. By using this active trace information, we do the contact tracing. Okay, so when creating active trace record, so actual trace record will be stored on the Connect mobile wallet with SSI approach. Proof will be uploaded to the record in the blockchain. So anytime admin officer can view the user's active trace records by directly fetching them from the user's mobile wallet. When user goes to a specific place, when showing the QR code, it trace mobile wallet has a feature to directly fetch the IT information as well as active trace information of the user and display it. So these are the active trace information. So dispatch airport, verified at BOC, renewals, all the active trace data will be stored on here. By using this information, so admin officer, anyone can identify what are the places he recently traveled. So in here, that this is how it works. So user connect tab, so show the QR code in the officer. So same as the previous scenario, request blockchain to verify the DID. So then directly fetch the identity information. So once verified, so it create active trace proof. So it saved on the proof on the blockchain, and actual active trace record, so basically location, time and everything will be saved on the user's Connect mobile wallet. Okay. So then let's look at how we use this information with the COVID-19 contact tracing. In here, that assume some point a user who registered in the Connect platform diagnosed as a COVID-19 infected person. So in that case, maybe user goes to the medical center. Maybe in that case, so he shows the QR code, and you know that in medical office at the hospital can report patient diagnosis information to the Connect platform via the Trace mobile wallet. So we provide the feature to medical officers or any officer to add the diagnosis information, and also user can self-report the diagnosis information via the Connect wallet as well. So we provide a feature to self-report the diagnosis information. So this diagnosis information will be also stored in the blockchain as a self-sovereign identity proof. Okay, so actually once COVID-19 case is reported into the Connect platform, the Connect platform can identify all the places where the patient has visited during last 14 days by using active trace proof data on the blockchain and the user's mobile wallet. So by using this information, so proof on the blockchain, actual data on the user's mobile wallet, so Connect platform identify all the places he visited during the last 14 days. So this active trace data contains information about the user's identity, time, location that a diagnosed patient has visited. So based on this active trace information, it can identify the other users who have been in these places at the same time with the COVID-19 infected person. So then Connect platform can send the notification to these users mentioning that there is a risk of getting contact with the COVID-19 infected person. So this active trace approach won't reveal any personal information of the users. It deals with only DID proofs. Actual information will be stored on the user's physical mobile wallet application. So that's how contact tracing works. So this is the way it works. So user diagnosis, so it report, so then blockchain save the diagnosis information proof. So find the active trace of the user in last 14 days. So find the places and times he have been in by using this activity trace data. So then find other users who have been in these places at the same time, so then notify to these people. So that's how active tracing works. So then we extend the other functionality as we build some COVID-19 hotspot information. For instance, so based on the active trace information on the blockchain, Connect identifies COVID-19 hotspots. The hotspot information will be shown in a map view on the Connect mobile wallet application. Hotspot critical level is decided based on the infected people count visited to a specific place. So this is how it's look like. So there will be red zone and green zone. Red zone means actually that considerable number of people visited, COVID-19 infected people visited to this place. So green zone means it's a safe place. So in that case, so this critical level will be decided based on the number of people who have visited to this place. All the data, all the decisions will be taken based on the active trace data. So in here that for instance this information will be shown in the mobile wallet. For instance, if I am going to some place, I can just show search that place and identify whether it's a red zone or green zone. So then I can decide whether I'm going to that place or not. So that's another additional feature we are providing. Okay, final Connect implementation. So we have done a production ready version of the Connect platform with collaborating with the Centera Hospital chain, Virginia, USA. So this is the high level architecture of this platform. So we built this platform on top of permission blockchain. We have used Rahasak blockchain to build this system. Rahasak is another work production ready blockchain platform that we have built. So based on our another research. So we built this platform as a microservices based architecture. So there are, you can see there are different services on the out service. So notification service, monitoring services, so storage services, etc. So all the inter-service communications happen via Kafka, Apache Kafka. So most of the services built with Scala language. So and some of the services built with Golang. So we have provided two mobile wallet applications. So I both for Android and iOS. So there are two type of mobile applications: Connect and Trace. Both support for Android and iOS. So that's the high level view of the architecture. So platform built with microservices architecture. Services are deploying using Docker and Kubernetes container orchestration system. So we build this platform as a microservice basically. So microservices communication will implement with Apache Kafka by using reactive stream based approach. So all the blockchain functions implement with the Rasa blockchain. So that's another blockchain platform that we have built. So it's a production ready blockchain which mainly targeted in the big data IoT kind of scalable enterprise level application scenarios. So monitoring services implemented the Prometheus, Grafana, and Kibana kind of monitoring services. So I have mentioned that there's a peer-to-peer communication between mobile wallets. That communication implemented with the Firebase notification messaging service. So and we have used Apache Cassandra-based off-chain storage. All the analytical information will be stored on there. For the authentication, so we and authorization, we have used JWT JSON Web Token based auth service. So that's the basically implementation details. So we have built a production ready version of this platform. Okay. Yes, so that's it from my side. So thank you very much for your time. So if you have any questions, we can discuss them now. Okay. Thank you very much.